Hello viewers, you are once again welcome to our channel. Today we're going to be looking at introduction to number systems. Our expectation is that by the end of this class you will be able to understand the various number systems that we have, and secondly you should be able to perform a basic expansion of our regular decimal number, which is numbers that are in base 10. It's very common when we talk about number system or our numerals for us to immediately think about numbers in base 10. However, we do have other number basics, and today at the course of this our class you will be able to understand the other number bases that we have, and as we progress we should be able to convert from one number base to another. So for our introduction, what do we mean by numeration systems? A group of symbols that can be used to express numbers is called numeration system. Also, the symbols of a numeration system are called numerals, and the size of the grouping in a numeration system is called number base or base of the numeration system. Now we're going to be looking at examples of number base systems that we have. Number one, we have decimal systems, which are also referred to as base 10. This comprises numbers or digits ranging from 0 to 9. Next, we have the binary system, which are also referred to as base 2. The binary system involve two digits, and they are 0 and 1, or you say 0 to 1. Next is the octal system, which is also referred to as base 8. This comprises 8 digits ranging from 0 to 7. Then lastly, we have the hexadecimal system, which starts from 0 to F. Here, when decoupled, we are talking about 0 to 9 and A to F. That is to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have A, B, C, D, E, and F, where A is equals to 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 15. These notations are going to be useful by the time we progress in this class and even in our subsequent classes when we'll be converting from one number base to another. So next, we're going to look at an example of something that is important, and that is the expression of numbers in base 10 in an expanded notation. Having a good understanding of this is going to help us when we will be solving problems under number-based system, which are basically conversion from one number base to another. So to solve this, we'll start with the first one. All these numbers are in base 10 and we need to express them in expanded notations. So the first one, we have 3, 1, 2. This is the same thing as, if you recall your unit, tens, and 100. So we can write 3 times, they are in base 10, 10. So 3 times, the first one is in 100, so we say 3 times 100 plus, we have 1 times 10 is this, then plus 2 times unit is 1. Now this is the same thing as 3 times 100 is 10 power 2 plus 1 times 10 is the same thing as 10 power 1 plus 2 times 1 is the same thing as 10 power 0. As we all know that any number raised to the power of 0 is 1. So this way we've expanded the given number in an expanded, we've expressed it in an expanded notation. So the next one, we have 1, 4, 6, 9, also in base 10. To expand it, you recall unit, tens, 100, and 1000. So we have 1, here is 1000, 1 times 1000 plus 4 times 100 plus 6 times 10 plus 9 times 1, which gives 1 times 1000 is the same thing as 10 power 3 plus 4 times 10 power 2. That is 100 is something as 10 power 2 plus 6 times 10 power 1 plus 9 times 10 power 0. So this is the expanded notation of the given number. If we observe something, we'll see that it is essentially having the given number, multiplying each digit of the given number by 10, whereas you put the powers of the 10 starting from this extreme end here. You have 0, 1, 2, 3. So you just put powers to the base, which is 10, and you start from 0, 1, 2, 3. Then we now go to the last one, which is number 3, where we have 7, 0, 2, 4, 3. This is in base 10. So this is equals to, we have 7 times, here we have unit, tens, unit, hundred, tens, thousand, 10,000. So we have 10,000 plus 0 times 1,000 plus 2 times 100 plus 4 times 10 plus 3 times unit. Now this is the same thing as 7 times 10. Here now we have 4 zeros, so we have 4 plus 0 times 10 power 3 plus 2 times 10 power 2 plus 4 times plus 4 times 10 power 1 plus 3 times 10 power 0. So you recall what we said earlier, that this can actually be expressed right away. So this is the expanded notation. So but then you recall what we said earlier, that to express it without going through all this rigorous this extended process, we can just look at the numbers and say 7 times 10 plus 0 times 10 plus 2 times 10 plus 4 times 10 plus 3 times 10. So we start from this end, we'll put powers on the base, which is 10, starting from 0, 0, 1, 2, 3, and 4. So that is the same thing as what we have as the expanded notation. So that is the answer to all the questions. Thank you for your attention. Please always endeavor to subscribe to our channel, like our videos. See you in our next class, when we are going to be looking at more detailed examples under number-based systems. We'll be converting from different base systems to base 10 and base 10 back to other base systems. See you in our next class. Thank you.